Please like and share my videos and subscribe my channel if you have not already subscribed. Thank you. There were 3 questions that are given on the topic indefinite integrals from the chapter Integral Calculus in the JEE Main examination held in January 2024 session. In this video, we discuss all the 3 questions. This question has appeared in the JEE Main exam held on 27 January 2024 in the second shift. The given question is the integral. It's a quotient. Numerator is x power 8 minus x square by the denominator is x to the power of 12 plus 3 times x to the power of 6 plus 1 in brackets in the denominator itself. Tan inverse of x cube plus 1 by x cube with respect to x is equal to. We are given 4 options, and you observe every option consists of a tan inverse of x cube plus 1 by x cube. It suggests us that we substitute t for tan inverse of x cube plus 1 by x cube in the given integral. Right. Let's now discuss the solution of the problem in detail. Put tan inverse of x cube plus 1 by x cube is equal to t. Differentiate on both sides, and that will imply 1 by 1 plus x cube plus 1 by x cube whole square into the derivative of x cube plus 1 by x cube, that is equal to dt. Right. And that is equal to, take the LCM in the denominator. The denominator will be x power 6 in the LCM, x power 6 plus x power 6 plus 1 whole square in the denominator, and that x power 6 will come to the numerator, into the derivative of x cube is 3x square plus the derivative of 1 by x cube is minus 3 by x to the power of 4 with respect to x. Now further simplify. If you simplify, now x power 6 plus x power 6 plus 1 whole square is x power 12 plus 2x power 6, and this x power 6 will give you 3x power 6 plus 1. So that is the x to the power of 6 by this into 3 into, take the 3 common and take the LCM, that will be x to the power of 4 in the denominator, that will be x to the power of 4 into x square, x to the power of 6 minus 1 by x to the power of 4. Now this x to the power of 4 cancels with this x to the power of 6, x square times. So x square into x to the power of 6 minus 1 is precisely x power 8 minus x square. So this is what we have obtained, and we see in the given integral, this portion is dt by 3. So we want x to the power of 8 minus x square by x to the power of 12 plus 3x to the power of 6 plus 1 with respect to x is dt by 3. Go into the given integral and substitute. So take that integral as it is and make a substitution. So that will be integral of dx by dt by 3 into 1 by t. The integral of 1 by t dt by 3. So 1 by 3, after integration it is log of mod t to the base e plus c, where c is the constant of integration. Now substitute for t. 1 by 3 log of mod of tan inverse of x cube plus 1 by x cube to the base e plus c. Right. This 1 by 3 we take inside the logarithm, and that will be log to the base e of mod of tan inverse of x cube plus 1 by x cube whole to the power of 1 by 3 plus c. So we stop here and see our answer tallies with the option 3. Therefore, the answer to this question is option 3, and that is the detailed discussion of this problem, and it is an easy question. Agreed. Let's move to the next question. This question has appeared in the 29th January 2024 in the first shift. The given question is, for x belongs to the open interval minus pi by 2 to plus pi by 2, if y of x is the integral, is again a quotient, numerator is cosecant x plus sin x by the denominator is cosecant x secant x plus tan x into sin square x with respect to x. And it is given to you limit of y of x as x tends to pi by 2 from left, that is the left limit is equal to 0, then the value of y at pi by 4 is equal to, we are given 4 options. Let's now discuss the solution of the problem in detail in the next slide. We have y of x is the given integral. X belongs to the open interval minus pi by 2 plus pi by 2. Convert everything in terms of sin x and cos x. That will be, for cosecant x, we write 1 by sin x and take the LCM. We will get 1 plus sin square x by sin x. For cosecant x, we write 1 by sin x. For secant x, 1 by cos x. For tan x, we write sin x by cos x. Right? And now further simplification will give you in the denominator 1 plus sin to the power of 4x by sin x cos x. This sin x cos x goes to the numerator and cancellation takes place, and the integral of 1 plus sin square x into cos x by 1 plus sin to the power of 4x into dx. What we see is it is in terms of sin x and cos x, and 1 cos x is there, remaining things are in terms of sin x. So let's now put sin x is equal to t. So then cos x dx is equal to dt. Substitute in that. So integral of 1 plus t square by 1 plus t to the power of 4 dt. Yes, this is, we know how to evaluate this integral. So this divide both numerator and denominator by t square, then you will get integral of 1 plus 1 by t square by t square plus 1 by t square dt. Yes. Now I know substitution. It's a well-known, prob methods, what we do in our earlier classes. Put t minus 1 by t is u, and then the derivative will be 1 plus 1 by t square dt is equal to du. And that is this 1 plus 1 by t square dt is du. And now in the denominator t square plus 1 by t square, and we have t minus 1 by t is u, squaring on both sides, t square plus 1 by t square minus 2 is equal to u square, but we want t square plus 1 by t square, that will be u square plus 2. So this will be integral of du by u square plus 2 dt, and this we will write it as integral of du by dt is not there, it's a typographical error, dt is not there, integral of du by u square plus a square, that is under the square root of 2 square. And we know integral of dx by x square plus a square is 1 by a into tan inverse x by a, and that is 1 by root 2 into tan inverse of u by root 2 plus c. Agreed. Substitute 1 by root 2 into tan inverse of u. For u we have written t minus 1 by t by root 2 plus c. For t we substitute sin x. 1 by root 2 to tan inverse of sin x minus cosecant x by root 2 plus c. Right. We have this relation. Y of x we have obtained. Right. For further simplification, we go to the next slide. Right. We have y of x is equal to 1 by root 2 tan inverse of sin x minus cosecant x by root 2 plus c. And we are given limit of y by x as x tends to pi by 2 from left is equal to 0. Is equal to 0. But you see, the x terms are sin x and cosecant x. Cosecant x is none other than 1 by sin x. Right. So now we find out limit x tends to pi by 2 minus, that is the left limit of sin x. But we know sin x is a continuous function, continuous at pi by 2. Therefore, the left limit is equal, right limit is equal to the value of the limit. Therefore, it's sin pi by 2. That is equal to 1. So now go and take the limit x tends to pi by 2 from left for this y of x. Therefore, when you take and it is given it is 0, 0 is equal to 1 by root 2 into limit x tends to pi by 2 from the left of tan inverse of sin x minus cosecant x by root 2 plus c. And tan inverse is again a continuous function, therefore x can be taken inside, and limit x tends to pi by 2 negative of sin x is sin pi by 2 is 1. So 1 minus 1 by 1. So it is 1 by root 2 into tan inverse of 1 minus 1 by root 2, that is 0. So tan inverse 0 plus c. So tan inverse 0 is 0. So c is equal to 0. Right. So then the c is evaluated and c is becoming 0. Now y of x is equal to 1 by root 2 into tan inverse of sin x minus cosecant x by root 2. Now we have to find out the value of y at x is equal to pi by 4. Take that. Right. And y at pi by 4. Wherever there is x, substitute pi by 4. Then you will get this one. And sin pi by 4 value is 1 by root 2. And cosecant pi by 4 value is root 2. Substitute in that. And now whole by root 2. Now divide by root 2, then 1 by root 2 by root 2, that is 1 by 2 minus root 2 by root 2 is 1. So 1 by root 2 into tan inverse of 1 by 2 minus 1. And this is 1 by root 2 into tan inverse of minus 1 by 2. Where is it? It's in the option 4. So the answer to this question is option 4. That is the detailed discussion of the solution of this problem. This is an easy question, except for it takes more time. It takes more time. That's all. Now let's move to the next question. This question has appeared in the JEE Main held on 29th January 2024 in the second shift. If integral of sine to the power of 3 by 2, 3 by 2 is not visible here, plus cos to the power of 3 by 2x by under the square root of sin cube x cos cube x into sine of x minus theta dx is given to be a times, capital A times under the square root of cos theta tan x minus sin theta plus capital B times under the square root of cos theta minus sin theta cot x plus c, where c is the constant of integration required to find the value of AB. Right. We are given 4 options. Right. Now let's now call the given integral as capital I is equal to integral sine to the power of 3 by 2x plus cos to the power of 3 by 2x by under the square root of sin cube x into cos cube x into sine of x minus 3 theta with respect to x. Now take out the sin cube x and cos cube x, take outside the square root, then it will be integral sine to the power of 3 by 2x plus cos to the power of 3 by 2x. If you take out sine to the power of 3 by 2x into cos to the power of 3 by 2x under the square root of expand sine of x minus theta, that is sin x cos theta minus cos x sin theta with respect to this. Now separate them. Sine to the power of 3 by 2, the whole thing, dx, plus integral cos to the power of 3 by 2, the whole thing with respect to x. Now this sine to the power of 3 by 2 x, sine to the power of 3 by 2 x cancels. Here cos to the power of 3 by 2 x and cos to the power of 3 by 2 x cancels. And in this first under the square root, we take out a cos x common. A cos x common. So let's see first what I have written. This is the thing. So under the square root of cos x is taken out, then it will be sin x by tan x, sin x by cos x, that is tan x into cos theta, minus cos theta minus sin theta. When cos x has come out, so cos x has come out. So plus integral. The second one, under the square root, you take out a sin x common and adjust the terms. So that will be sin x is taken out, cos theta minus sin theta into cos x by sin x. Cos x by sin x is cot x. Right. Yes, we got it. And now this cos x will come out of the under the square root, that will be cos to the power of half, and cos to the power of 3 by 2 will be cos square x. And this sin x will come out as sin to the power of half and sin to the power of 3 by 2, and this is sin square x. So this will be integral of 1 by cos square x into under the square root plus integral of 1 by sin square x under the square root of dx. Whatever is under the square root above is there, that we have written. So thus we have I is equal to 1 by cos square x, we have written as secant square x, integral of, plus 1 by sin square x, we have written as cos square x, cosecant square x. Right. Let's now go to the next slide. We have the given integral is split into, this is the given integral, is split into sum of two integrals. These are the two integrals what we have seen in the last slide. Let's call this as I1, this as the I2. You will get I1 plus I2, where I1 is the first integral and I2 is the second integral. Agreed. Let's now evaluate I1. Right. So what we have done, put tan x cos theta, which is appearing here, tan x cos theta minus sin theta in the denominator, that is equal to u. Differentiate. You will get secant square x cos theta, because cos theta is a constant here with respect to x is the variable, is equal to du. And what we want, secant square x dx, that will be du by cos theta. Go back and substitute in I1. I1 is equal to integral of secant square x dx is du by cos theta into 1 by root u. 1 by cos theta is constant, comes out, and 1 by root u, integral is root u by 1 by 2, that is 2 root u plus c1. That will be equal to 2 by cos theta under the square root of u tan x cos theta minus sin theta plus c1. Agreed. Go back to I2. Substitute this under the square root cos theta minus sin theta, cos theta minus sin theta into cot x as v. Now differentiate. That will be cosecant square x minus cosecant square x, but there is already a minus, cosecant square x sin theta dx. So we want cosecant square x dx, that will be du by sin theta. Now go back and substitute in I2. That will be integral of 1 by root v into du by sin theta. That is 1 by sin theta into integral of 1 by root v dv, it's not du, it is dv, It's not du, it's not dv, it is dv. It is dv. It will be 1 by sine theta into under the square root of root v by 1 by 2 plus c2. And that is 2 by sine theta into under the square root of v. V is cos theta minus sine theta cot x plus c2. Agreed. 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 So, right. So, these are not du I have written, that is a print mistake, typographical error. It is dv. Right. Let's go back. Go to the next slide. So that's what we have. I1 we have evaluated, we got the answer. And I2 we have evaluated, we got the answer. Now substitute. Therefore, I is equal to I1 plus I2. So I1 is 2 by cos theta under the square root of tan x cos theta minus sin theta plus I2 is 2 by sin theta under the square root of cos theta minus sin theta cot x plus C1 plus C2 that we have written as C, where C is the constant of integration. Agreed. Agreed. But it is given this integral I is equal to a times under the square root of cos theta tan x minus sin theta plus b times under the square root of cos theta minus sin theta cot x plus c. It's given. That means they are equal, means a must be equal to 2 by cos theta, b must be equal to 2 by sin theta. But what we want? We want AB. AB is equal to 2 by cos theta into 2 by sin theta, that is 4 by sin theta cos theta. Now multiply both numerator and denominator by 2. So that will be 8 by 2 sin theta cos theta, and that will be 8 by sin 2 theta, that is equal to 8 times cosecant 2 theta. Cosecant 2 theta. So let's now look at our options. Our answer 8 times cosecant 2 theta appears against option 3. Therefore, the answer to this question is option 3. Option 3. And that is the detailed discussion of this problem. This problem, we can say, it is easy, but it will take time. But it will take time. Right. And in this video, we have discussed these three questions on indefinite integrals which have appeared in the JEE Main exam, held in January 2024 session. I am sure that you have understood the solutions of these 3 problems. I request you, please like and share my videos and subscribe my channel if you have not already subscribed. I wish you all the best. Thank you.